All right. Hello, everyone. Welcome back to Comp 433. As you all know by now, our lectures are going to be recorded and posted online until you get back safe and sound to the university. We are going to try our best to make the course complete with the labs. The lab instructor will provide you with the lab tutorials. However, you are all encouraged to follow up with us with the lectures and with the lab sessions and do practical practice at home. And whatever questions you have, you may email us. Of course, we're there for you, Hoda and me. All right. So don't hesitate to follow up with your courses and take a rest at home. And we hope to see you soon, inshallah, when things get better at VAU. So we have reached to a point in our course, which is relational algebra. So why study relational algebra? You all know that database systems, most relational database systems use query language is the standard for all modern database systems today. They all use query language. This query language, which is an international standard, is actually based on relational algebra. So the flexibility and the different complex operations that you can do in the query language, including retrieving data, updating data, adding records to the tables, many other complex operations, which we'll talk about throughout the course. They are all possible behind the scenes. They're all based on relational algebra for correctness. So we're going to discuss in this lecture the relational algebra functions on which the query language is based on. So let's recall query language. Query language is, we have to make sure that you have to keep in mind that query language is not a programming language, which means you can't find the complex programming functionalities like selection structures, if else, and iterative structures, the for loop, the while loop. So you cannot see those in query language. This standard language is used basically for manipulating databases. Okay, it's not a it's not a programming language. It's not it's not a complete programming language. And usually you will find SQL functions embedded inside programming languages like C, C++, Java, all actually programming languages have functions that allow you to use a query language in order to access the database and manipulate data in it using the query language. Although of some relational databases like Oracle have PLSQL, which is a query language with it has additional programming capabilities in which you can do programming structures like if else and functions and all these loops. Okay, but it's good to keep in mind that the query language is basic and it's oriented towards relational databases. So we're saying here in this slide that the relational algebra, like it's an abstract model and it's implemented in query language. So the abstract models, yeah, like any math topics and math rules, these topics are actually, as you all know, abstract. However, the implementation is through the SQL language. All right, so what we're saying here, a query is applied to relation instances and the result of a query is also a relation instance. In a query, you input a relation and the output is also a relation. So there's a logical functions, the input is a relation and the output is a relation. And the result of a given, the schema for the result, which is the structure of the result, is fixed, and the input is fixed. That is, you have an input a relation, and the output is a relation. Okay. There's something called positional versus named field notation. You'll see it in SQL. Let's to continue now with the relational algebra.